Hello everyone, welcome back to Cambridge Guru. In the last video, we did some examples on HCF and LCM, and we also learned something what is called as bid mass, meaning order of operations. In this video, we will see the laws of indices, or this is a plural form of index. Sometimes we also say laws of exponents. Okay. So what are laws of exponents? These are useful to simplify certain algebraic expressions, right? Algebraic expressions which involve terms written in exponent form. Okay. So for example, you consider one number, let us say 32. This 32, if I write in its prime factorization form, this can be written as 2 multiplied by 2 multiplied by 2 5 times, right? So this can be written as 2 which is raised to power 5. This is pronounced as 2 raised to power 5. So this is called the exponential notation of the number 32, or exponent form of 32, which is 2 raised to power 5. Okay. Now in this 2 raised to power 5, this 2 is called the base of, or just the base, right? And this 5, this is called the exponent, and or sometimes it is called as index. So as I said, indices is the plural form of this index or the exponent. Okay. So what are the laws of indices, or the laws of exponents? So let us see those. The first law of exponent is, if I take a number x, it is raised to power m, and this x raised to power m is multiplied by another number which is x raised to power n. As you can see, the exponents are different, so these two numbers are different. So it says that if same bases are multiplied, then exponents get added. So x raised to power m multiplied by x raised to power n gives you x raised to power m plus n, right? So in language we can write that same base, if same bases are multiplied, then exponents get added. Okay. Now how we can verify this? You just take any example. So example you can take as, let us say we have 2 raised to power 3, it is multiplied by 2 raised to power 2, right? So without applying the law, if we need to calculate this value, so what is 2 raised to power 3? This is 8, and 2 square is 4. So left hand side is giving me the answer as 32. Now if I apply the law using the right hand side, so I can write this 2 raised to power 3 multiplied by 2 raised to power 2 as 2 raised to power 3 plus 2. That if same bases are multiplied, then exponents get added. So I have added the exponent. So this can be written as 2 raised to power 5, whose value is 32, right? So hence left hand side and right hand side are equal. So law is verified. Okay. Very easy. Second law of exponent says, which is just the reverse of this. Reverse in the sense that since we have talked about the multiplication, the second law says that if same bases are in division, that if x raised to power m is divided by x raised to power n, then it says that instead of adding the exponent, we subtract the exponent. So x raised to power m minus n. This is the law. Again, you can verify, right? For verification, you can take an example, let us say 3 raised to power 4 over 3 square. Without applying the law, if 3 raised to power 4 is 81 and 3 square is 9, so answer is coming out to be 9. So by applying the law, answer should come out to be 9. So by applying the law, 3 raised to power 4 over 3 raised to power 2 can be written as 3 raised to power 4 minus 2, that I have subtracted the exponent seeing the same bases are in division. So this is nothing but 3 square, which is 9. So hence the law is verified. So in words you can write that if same bases are in division, then exponents get subtracted. Okay. All right. Then we have the third law of exponent, which says that if a number x raised to power n is again raised to power some other exponent which is n. So this in sentence we say that exponent of an exponent. If some number is raised to power 1 exponent and the whole is again raised to some other exponent, so the law says that exponent gets multiplied. So x raised to power, simply we can write mn, right? And if this is true, right, I can again write this as x raised to power mn can be written as x raised to power n into m, right? Mn can be written as x raised to power nm. So this can be written as x raised to power n and then raised to power m. So now this is very important. You can say deduction from the original law. And what is that deduction? That if x raised to power m is raised to power n, you can interchange the exponent. So this can be written as x raised to power n raised to power m. Okay, and let me complete this first. So, and this can be written as x raised to power just m into n. Okay, and this law is very important, and its importance you will get to know when we will learn the rational exponent, when the exponent is not an integer, rather it is in some fraction form. So how to deal those type of questions we will just learn in few minutes. So for now this is the law. Again you can verify by taking one example, that 2 raised to power, let us say 2 raised to power 3. Without applying the law, I can say that this is 2 raised to power 2 is 4 raised to power 3, which is 64. And then applying the law, it says that exponent gets multiplied. So 2 raised to power 2 multiplied by 3 is equal to 2 raised to power 6, which is nothing but 64. And again you can interchange the exponents also. Okay. So in words, how we can say, how we can define the law, and definition or just the wordings are that x raised to power, if a number is raised to power an exponent, then it is again raised to some exponent, and we say that exponent gets multiplied. Okay, so exponent of exponent gets multiplied. This is how you can say. Okay, now we come to the next law, the fourth one. Now this time bases are different. That if a number x is raised to power m, it is now multiplied with some other number y, but the exponent is same. Okay, this is very crucial, or it creates a confusion between law 1 and law 4. Here exponents are same but bases are different. In both law 1 and law 4, the numbers are in multiplication. There is nothing added for now. So how we can write this as, we can combine these two numbers, meaning we can first multiply these two numbers, or bases, not numbers. We can multiply x with y, and this can be written with a single exponent m. How we can verify? Again, by taking some simple example. Let us say 2 raised to power 3 into, let us say 3 square. Okay, so before applying the law, 2 cube is 8 and 3 square is 9. Answer, it is giving me as 72. After applying the law, oh, I'm sorry. I need to keep the exponent as same. Okay, this is 3 cube. So 8 into 27. This is giving me the answer. 8 into 7 is 56. This is 216. Yes. Okay. Now, after applying the law, it is giving me that instead of multiplying this, I should multiply 2 and 3. So 2 into 3 raised to power 3. 2 into 3, not 6. 2 into 3 raised to power 3. So this is basically 6 cube, and 6 cube is actually 260. So law is verified. All right. Next law of exponent is number 5, which is very easy, that if something raised to power 0, this is always 1. Something raised to power 0 is always 1. Okay, and this something can be anything, right, except 1. Except 1, and this is very important. For example, let x is 1, and this is very interesting. If you follow the following 3 to 4 minutes, that here I can prove that 1 is equal to 0, right? So if you are not applying this condition, that if bases are same and exponent are same, this is only valid when bases are not equal to 1. Okay, so for example, let us take base as 1 and see what happens to the law. So let x is 1, so 1 raised to power 0 is equal to 1. So this 1 again can be raised as 1 raised to power 1. So if bases are same, exponents are equal, so here you are getting 1 equal to 0, which is not possible, obviously. So what is the flaw? The flaw is that we have taken the basis as 1. All right. So when we are comparing something raised to power 0 is 1, here x cannot be equal to 1. Okay. It is just 1 equal to 1. I cannot take this x equal to 1. Right. So this is the law. Something raised to power 0 is always 1, and this something can be anything: positive, negative, fraction, square root, irrational number, even imaginary number also. What are imaginary number? That we will do later on, and that is a part of AS and A level. But for now, consider this base just not equal to 1. All right. Then sixth law is any number which is raised to power, let us say, minus m, if the index is negative. If the index is negative, the law says that it can be written as 1 over x raised to power m. Okay, what is the proof for this? Why x raised to power minus m is written as 1 upon x raised to power m? Okay, the proof for this is very simple, and it is just an extension or the special case of second law of index, which is division. Okay, so I can write this x raised to power minus m. I can write this as x raised to power 0 minus m. 0 minus m is minus m. Of course, we can write. Now, if exponents, there is a subtraction in the exponent, I have the law in reverse, that I can write this as x raised to power 0 over x raised to power minus m. If you go in this direction from here to here, you will get the step as that if same bases are in division, then exponent gets multiplied. Here exponent gets subtracted, sorry. So here exponents are in subtraction with the base x, so I can separate these exponents and can be written as x raised to power 0 over x raised to power minus m. Now, as we know that x raised to power 0 is 1, so this is 1 over x raised to power minus m. This is a proof. For verification or for applying the law, you can take any example. Okay, although this is the proof, I'm not verifying this. I'm just giving you some example to apply this rule. Okay, so 3 raised to power minus 4 is equal to the motive of this minus is just to reciprocate this. Just remember this. 3 raised to power minus 4 won't be negative. Exponents cannot be negative until and unless base is positive. Okay, so 3 raised to power minus 4, please remember, is a positive quantity. So no need to get panic or confused. No need to get confused and write this as minus 3 raised to power 4. This minus has nothing to do with negative number. No, the only motive of this minus 4 is to reciprocate this 3 raised to power 4. So just write 1 over 3 raised to power 4. Okay. All right. And the last law is of rational number exponent, or if the exponent is given in the form of p by q. Okay. So if any number x is written as some exponent of p over q. Okay. Although this is not again a law, this is just an extension of the law which is x raised to power m and raised to power n, x raised to power mn. Okay, so I can write this as x raised to power p raised to power 1 over q. I can apply the law that x raised to power p will get multiplied by 1 by q. So this is written in fact as x raised to power p by q. And if this is true, I also learned that this can be written as that exponents can get interchange. This can be written as raised to power p. Okay, now how to deal with questions which involve exponents in rational form or in fraction form. Okay, so let us take some examples of laws of exponents. Okay, I have given you the examples of the previous laws, but let us consider some more complicated questions which involve exponent in fraction form. Okay, so the example is this. Let find the value of 125 raised to power 2 by 3. The method which I used to follow, okay, there can be other method also, but this looks easier to me. So what that method is, that you look at the denominator of the fraction exponent, which is 3. This is the denominator of the fraction which is in the exponent. So this 3 is there. So this number 125, please listen carefully, that this number 125 should be written as something, some other number whose exponent should be 3. Why I am saying this, it will get clear soon, that this number 125 should be written with some base a and it should raise to the exponent 3 or whatever is in the denominator. Okay, so if I have to generalize this result, that if we have x raised to power p by q, and we need to find out this, okay, evaluate this. So how we can do is, I should write this x as some number a which should be written as an exponent of q, and then you just apply this p by q so that this q gets cancelled out. How it will get cancelled out? By applying the law that exponent of exponent gets multiplied. Meaning is, this will be written as x raised to power q into p by q. So you can cancel this q with q. So you will get x as a raised to power p. Okay. So let us do this question. As I said, I need to write this 125 something raised to power 3. Okay, and what is this, that something? I know that 125 is the cube of 5, right? So this 125, I will write this as, let us take 125 raised to power 2 by 3. This is equal to, I will write this 125 as 5 cube raised to power 2 by 3. As you can see here, what is the benefit of writing this is that when I multiply the exponent, this 3 gets cancelled with this 3, you only remain with 5 square, which is 25. Okay, so this is 5 raised to power 3 multiplied by 2 over 3. So we have 5 square, which is 25. This is the answer. Okay, so I'm repeating the step. What is the step? That if there is an exponent which is written in fraction form, just look at the denominator, and whatever is inside the bracket or whatever is the base, you should write that base which should be raised to some number with an exponent which is equal to the value of the denominator. Okay, let us take another example to solidify the concepts. For example, example 9. Just pause this video and try to solve on your own. So we have to simplify this. So 16x raised to power 16 raised to power 3 by 4. There is another law which I forget, that you may note it down, that if x raised to power x into y are raised to power m, yes, this we have done, I didn't forget. I will apply this law. So I can write this as x raised to power n into y raised to power m. Okay, remember we have done this here. Okay, here we have applied the law in reverse, right? We have been given the question of this type, that there is a single exponent and there are two different numbers inside the bracket. So I can separate these exponents and write these as in multiplication. Okay, so I have written the given question like this, that 16x raised to power 16 into raised to power 3 by 4 can be written as 16 x raised to power 16 raised to power 3 by 4 can be written as 16 raised to power 3 by 4 into x raised to power 16 into 3 by 4. So far so good. Now this is 16 raised to power 3 by 4. We will deal it later. Let us simplify this, because this 4 gets cancelled with this 16. It goes 4 times. So 4 into 3, 12. So the second part is done, that it is x raised to power 12. Now we need to deal with 16 raised to power 3 by 4. So again, remember that if something is raised to power 3 by 4, the denominator is 4. So I need to write this 16, which is written as something raised to power 4. And I know that 16 is in fact 2 raised to power 4. So I will write this 16 as 2 raised to power 4 raised to power 3 by 4 into x raised to power 12. Okay, so exponent gets multiplied, you get 2 raised to power 3 into x raised to power 12. So answer is just 8 x raised to power 12. This is the answer. Okay, let us do one more question. Now here we have 2x raised to power 3 by 2 is equal to 54. You need to find out the value of x. As you can see, in left hand side there is no exponent in 2. The exponent is just on x. Similarly, on right hand side, 54 cannot be written as something raised to power something, so that you get 54. Right? Meaning is we cannot find any integer value of x or m. As you must be noticing, in all these questions, we are dealing with integer value. Okay? X raised to power 16, 16, then 3 by 4. So, integer value in the sense that 54 cannot be written using some numbers which are integers, such that that integer raised to some integer comes out to be 54. Okay? So, we need to just readjust the given question. The point is this. How we can readjust is by transferring this 2 to right hand side in the division. So we get x raised to power 3 by 2 is equal to 54 over 2. So x raised to power 3 over 2 is in fact 27. Now the moment I say C27, I remember that yes, 27 is the cube of 3. Okay, so I can write this 27 as 3 cube. Since we are dealing with exponents, so whatever is given to us in numbers, I need to write those numbers in some exponent form. So the moment I see 27, I can write this as 3 cube. Initially it was 54. I couldn't write this 54 using some exponents, known exponents. Okay. So x raised to power 3 over 2 is equal to 3 cube. Fine till now. Now, if you remember, I said that whenever there is some variable in the exponent, then bases should be same. So if bases are same, we can compare the exponents. Vice versa is also true. That if exponents on both the sides of an equation are same and variable is in the base. So if exponents are same, then bases should also be same. If they are only single terms. Okay, remember this condition. Not for, I mean, if it is y raised to power something, then we cannot compare. Okay, since we can see there is only a single term, so bases should also be same. Now here on right hand side, it is written 3 cube and variable is in the base. So I need to make the exponent on left hand side that should be written with some cube. Only I can deal on left hand side is with the exponent, and I need to make exponent as equal to the exponent on right hand side, which is 3. So I should write this x raised to power 3 by 2 as x raised to power 1 by 2 whole power 3. Okay, this is exactly what I wanted to convey, right? So this is 3 cube. Now, as you can see that exponents are same on both the sides, so bases should also be same. Okay, so this was the motive behind all these efforts. Okay, so now I can compare the bases that x raised to power 1 by 2 is equal to 3. This is equal to this. So I can square this. So the moment I square it, x raised to power 1 by 2 square is equal to 3 square, meaning is x is equal to 9. Okay, so that's all as far as exponents is concerned, right? And we will deal with exponents later on in the, not in this chapter, but since we are dealing with number, so all the concept that we will learn in this number, they will reappear in some other form in other units. Okay, in algebra also we will deal with the exponents. But for now, thank you.